Welcome guys and girls to this video. In this video, we are going to go over a very popular topic these days, which is how to use Kubernetes to provision and manage other AWS services such as Lambda. I just released an official AWS blog going over this particular topic along with hands-on demo. I'll give the link to my blog in the description. Please check it out. Alright, so let's start with the announcement. The announcement is using ACK or AWS controllers for Kubernetes. Now you can deploy Lambda from Kubernetes using this ACK or AWS provided controller. What is the benefit? Benefit is you do not need separate infrastructure as code or DevOps pipeline to provision your Lambda. So using ACK, you can use Kubernetes manifest files to create, update, and delete AWS resources such as Lambda. You don't need to write additional Terraform, CloudFormation, etc. I'm sure all of you folks are thinking, what the heck is a controller? So let's understand that first. So if we look at a Kubernetes cluster, it has two main components, control plane and worker plane. And some of the main component of control plane is API server, controller manager, and scheduler. And your worker plane is typically EC2 worker nodes where your application will be running. Now let's say you, the almighty developer, submits this Kubernetes manifest file where the kind is deployment, where you create your container. So in this case, we are creating Nginx version 1.16 and 3 replicas. So how this works is, as soon as you run kubectl apply -f and this manifest file, that request actually goes to the API server, and this controller manager has separate controllers for different kinds. So in this case, the kind is deployment, and the controller knows what it needs to do with this kind deployment. So in this case, working with scheduler, it creates 3 pods in the worker plane under this deployment because the replica is 3. Similarly, whenever you submit other manifest files with kind such as namespace, service, etc., the controller knows what to do with all these kinds. With namespace, it can create a separate namespace. With service, it can create a load balancer service or other kinds of service, etc. Because all of this kind or Kubernetes object is defined when you run a Kubernetes cluster. Now, what if you say, I really like this Kubernetes thing, I want to deploy an object like Lambda using kind:function. So this is your manifest file where the kind is function. So you submit this and it goes to the API server, but the controller has no idea what to do with this kind function because this object type function does not come with default Kubernetes. It is a custom object. So you need to tell Kubernetes what to do when someone submits of kind:function. So that's where AWS Controller comes into play. So to work with this custom object such as function, you need to do a deployment. And this deployment will create a custom controller as well as CRD or custom resource definition. And together, this is AWS Controller for Kubernetes or ACK. So this deployment will create a pod which is Lambda controller along with a CRD or custom resource definition. I put CRD outside of this EC2s because EC2 is like AWS construct and CRD is a logical construct, so it's not really running inside a pod or anything. But the CRD or custom resource definition defines if someone submits a manifest file with the kind function, do this, create this Lambda function, etc. So you need to write some sort of code to tell Kubernetes what to do and how to do it. For ACK or AWS Controller for Kubernetes, AWS is giving you the code, so you don't need to do anything. You just run this deploy and then it's done. So at this point, this Lambda controller pod is constantly watching if there is a kind function kind of object being submitted. So in this case, it is. So it is going to work with the CRD to know what it should do, and then it reads from the manifest that you submitted, and then it can go and define AWS Lambda. So one thing to keep in mind, this Lambda controller pod needs to read the Lambda deployment package either from a S3 bucket as a zip file or as a container image from ECR. So it needs to have access to read the Lambda deployment package as well as the access to deploy, update, delete AWS Lambda. So you do that using IRSA. And during my demo, I'll show you how it's done. And another advantage, if something goes wrong, you can always open an AWS ticket and AWS will help you troubleshoot this. Similarly, Lambda is not the only controller you can have. Using this same flow, you can create S3 bucket. So instead of a Lambda controller, you'll have a S3 controller, and the CRD will define what it needs to do if someone submits with a kind bucket. So in this case, this controller pod needs to have access to deploy, update, delete bucket. So the pod can read any manifest file with kind bucket and go create this bucket. So when is Lambda ACK useful? So in the blog, I have provided 3 distinct use cases where you should consider using this feature. Check it out. I'm not going to go through it in this video. All right, let's jump into a demo. I'm going to actually have 2 different demos for this. One is how to deploy Lambda from S3 bucket with a zip file. This is the most common way to deploy Lambda. And also how to deploy Lambda from container image stored in ECR or Elastic Container Registry. All right, so let's jump into the blog and follow the steps for the demo. Before we get started, you need all these prerequisites. All right, let's start create our EKS cluster. So I'm just going to run eksctl create cluster. This command will create a 2-node Amazon EKS cluster with a unique name. So creating cluster may need 15 to 30 minutes. So I'm going to pause the video and come back when my cluster is up and running. All right, the cluster is up and running. To validate it, we run kubectl get nodes. We should get back 2 nodes that are up and running. Now we are going to get the name of the cluster and save it in this variable. Just going to copy this name, paste it here. Now we need to set up the ACK controller. So the first step is install an ACK controller with Helm by following these instructions. So I'm going to right click, open link. Also in this instruction, I have called it out that changed the export service equal to S3 to Lambda. Also changed the region appropriately. So here export service equal to S3. I'm just going to copy that line. Go here, paste Lambda. And I'm already running in USOS 2. So I'm going to keep everything as is and just copy up to here, go back to Cloud9, paste everything. All right, so our Lambda controller is deployed. So now at this point, the Lambda controller is up and running. But remember, for this controller pod to deploy Lambda, it needs to have the permission to read the deployment package either from S3 bucket or a ECR. It also needs the policy to create, update, delete Lambda. So that's what we are going to do in this number 2. Right click, open link in a new tab. Okay, so the first things first, we need to create a OIDC identity provider. So we already have the EKS cluster name. We set this variable up. So I'm just going to copy this export region, set region to USOS 2. And then I'm just going to copy this line and enable the OIDC provider. Okay. Now step 2, create an IAM role and policy for your service account. So don't run this part. This part is only for OpenShift. We are not running OpenShift. So here the first line, service equal to S3. We need to update it. And then I'm just going to copy everything as is. Control C. EKS v2. Let me just clear it up. Paste everything here. All right. So at this point, if I go to IAM, refresh this, we have this ACK Lambda controller, but it has no policies attached. So next, we are going to attach the policies that's needed. So this will attach to read from S3, ECR, as well as Lambda create, update, delete. So go back to Cloud9, clear everything up again. All right, so if I go back to IAM, refresh, here you go, ACK recommended policy. So this has S3 get, ECR get, and Lambda asterisk permission. Okay, so finally, we are going to associate this IAM role to the service account and restart the deployment. So if we copy this, paste it here. So here we are going to copy this. This is what will attach that IAM role to the service account. And now we need to restart the deployment. Okay, so here, this is the name of the deployment. So here we need to copy that and paste it here. It restarted. Step 4, verify successful setup. So let's copy this. So this is going to display the pods in that new namespace. All right, you could see the controller pod is running. So this is the pod which is going to read the deployment package for the Lambda and also create the Lambda function. So at this point, we are ready to provision our Lambda function from this Kubernetes cluster. So I'm just going to create a sample hello world Lambda function, and I'm going to zip it up and create a deployment package. You can just copy everything, paste everything. See, my hello world function folder got created with Lambda function and deployment package. If I open the Lambda function, pretty straightforward, just hello from Lambda, nothing crazy. I wanted to keep this example simple. Second, you need to create a S3 bucket following the instructions here. Alternatively, you can use the existing S3 bucket in the same region of the Amazon EKS cluster. So this part is important. So our EKS cluster is running in EOS 2. So I need to pick a S3 bucket in EOS 2. So I have this bucket Raj Saha Lambda code version 1. This is in the same region as the EKS cluster. Similarly, you can pick a S3 bucket. This S3 bucket is empty. So I'm just going to copy this name, come back here. So export bucket name, and then paste the S3 bucket name here. And then we are just going to copy this deployment package into this bucket. All right, it's copied. If I go to the bucket, refresh this, here you go, my deployment package. Now we are going to create the Lambda function. First, we are going to choose the name of the Lambda function. So for our case, hello world S3 ACK, paste this here. Now we are going to create and deploy the Kubernetes manifest file. So I'm going to copy this, and I'm going to explain this as well. Let me just copy this, go back to Cloud9, clear this up, paste this here. Okay, so before I run this, let me explain the manifest file. So this created this file, lambda manifest.yaml. So if I double click, so you could see the kind is function. So because we deployed the Lambda controller, it also deployed a CRD, and using both of those two, now it can act on this kind function. So this is a custom resource. So the name of the Lambda will be hello world S3 ACK. The code is in S3 bucket. This is the S3, and S3 key is the name of the zip file. So my deployment packet.zip, and the role is the role that will be attached to the Lambda. So this is Lambda basic execution. So for hello world, you don't need anything extra. Runtime is Python 3.9. Handler is standard Lambda function handler, and then the description. So let's run this Lambda manifest kubectl create. So the function is created. So if I run kubectl get function, so generally you run kubectl get pod, get service, etc. But now, since we have the controller defined, it will bring back the Lambda functions that are created. So now this is a Kubernetes object. So let's go to the Lambda console. Okay, last modified 1 minute ago, hello world S3 ACK. If we go back in, all right, here is our function. Let's go back to the blog. So now let's invoke the Lambda function and find out what the response is. Okay, and then cat. All right, so the Lambda function ran and gave us a successful output. So congratulations, you created a Lambda function from your Kubernetes cluster. So what that means is you can also delete the Lambda function. So basically, if you run kubectl delete function and then give the name of the Lambda function, it will delete the Lambda function as well. And if you have GitOps set up, even if you delete it from here, it is going to read from the GitHub repository and recreate the Lambda function. We have also created how to deploy the Lambda from the OCI container image. So it is here, and I'm going to cover this in a separate demo. If you have been following along with me with this demo, please make sure you clean up the Lambda function, IAM role, as well as the EKS cluster, because EKS cluster will incur some charges. All the cleanup instructions are also given in the blog. If you found this Lambda ACK concept as well as the blog useful, please click that like button, click subscribe, ask me any questions on this in the comment. Also, if you're interested, check out my highest rated and best-selling serverless, Kubernetes, GitHub, infrastructure as code, DevOps courses in Udemy, the maximum discounted link in the description. Buying my courses is an excellent way to support me and this channel. Alright, that's it for this one. I'll see you guys and girls in the next video. Bye.